scene script. Ever wondered how computers communicate with each other? Well, that's where the magic of networking comes into play. Networking, in its most basic form, is the practice of linking two or more computing devices together with the goal of sharing data. It's a bit like a conversation between two people, but instead of words, computers use data packets. Now, imagine a world where every computer is an island, isolated and unable to communicate with other computers. It's a bleak picture, isn't it? But thanks to networking, this is far from reality. Networking allows computers to share resources, exchange files, and generally communicate in a coordinated and efficient manner. The beauty of networking lies in its versatility. It can be as simple as connecting two computers in the same room, or as complex as linking millions of devices across the globe. The internet, that vast web of interconnected devices that we all use daily, is the ultimate example of networking on a grand scale. But how does this all happen? How does a picture from your recent vacation or that important project report travel from your computer to another halfway across the world? The answer lies in protocols, or sets of rules that dictate how data is sent, received, and interpreted. Think of protocols as the language of networking. Just as people from different countries use different languages to communicate, computers use different protocols to exchange data. And just like in human languages where we have English, Spanish, French, and so forth, in the world of networking, we have various protocols such as HTTP, FTP, and SMTP. However, there's one protocol that stands tall above the rest, forming the backbone of how we network and communicate in the digital world. It's called TCP/IP, short for Transmission Control Protocol, Internet Protocol. It's the standard language of the Internet, the protocol that enables all online communication. Now let's delve into the heart of networking, a protocol called TCP/IP. Ever heard of TCP/IP and wondered what it means? Well, let's unravel this mystery together. TCP/IP stands for Transmission Control Protocol, Internet Protocol, and it's essentially the language of the Internet. It's a suite of protocols that computers use to chat with each other over the Internet. You see, in the world of networking, communication isn't as simple as just sending a message from point A to point B. There's a whole lot of back and forth checks and balances, and that's where TCP/IP comes in. Let's break it down a little further. The TCP/IP model comprises two layers: the Transmission Control Protocol, TCP, and the Internet Protocol, IP. The TCP is like a meticulous mail sorter. It takes data from applications, breaks it down into bite-sized packets, and then ensures they are delivered to the right IP address. It's also responsible for checking that all packets have arrived safely. If any are missing or damaged, TCP orders a retransmission. So it's all about making sure the message gets through correctly and completely. On the other hand, the Internet Protocol, or IP, is like our postman. It's responsible for taking these packets from the source machine and delivering them to the destination machine. It doesn't worry about the order or the integrity of the packets. Its main job is to get them to their destination. So you see, TCP and IP work together as a team. TCP is the meticulous one, breaking down data and making sure everything is in order, while IP is the reliable delivery guy, ensuring those packets get to their destination. Together, they form the backbone of all internet communications, making sure that when you send an email, stream a video, or browse the web, your data gets where it needs to go, in the right order and without any pieces missing. So, in essence, TCP/IP is the language that computers speak when they want to communicate over the internet. So, how does this TCP/IP magic happen? Well, let's dive in. The Transmission Control Protocol, Internet Protocol, or TCP/IP, is like a two-man team working together to ensure that data is sent and received reliably over the internet. TCP/IP's work begins when you, for example, click a link on a web page. The data you're requesting is broken down into small packets by TCP. Think of these packets as tiny parcels, each containing a slice of the information you're after. Now, it's the Internet Protocol's turn. IP is like the postman of the internet world. It takes those packets, each with their own destination address, and sends them out into the digital world. It's IP's job to find the best route for each packet to reach its destination. But the internet can be a chaotic place. Sometimes these packets can get lost, delayed, or arrive out of order. This is where TCP steps in again, like a quality control manager. It keeps track of all the packets sent, ensuring they all reach their destination. If a packet gets lost along the way, TCP sends a message back to the source, asking for that packet to be resent. If the packets arrive out of order, TCP rearranges them back into their original sequence. Once all the packets have arrived at their destination, they are reassembled into the original data you requested. So, whether you're watching a video, reading an article, or sending an email, TCP/IP ensures the data is delivered correctly and in order. In essence, TCP and IP work together in a marvelous dance of data transmission, ensuring that the internet remains a reliable and efficient tool for communication and information sharing. So the next time you click on a link or send an email, take a moment to appreciate the intricate work that goes on behind the scenes to make it possible. TCP/IP, therefore, is like a reliable courier that ensures your data gets to its destination correctly and on time. Why is TCP/IP so crucial in networking? Let's dive right into that. TCP/IP, or the Transmission Control Protocol, Internet Protocol, is the lifeblood of our interconnected world. It's essentially the language that computers and other devices use to communicate with each other on the internet. Like the universal translator in a science fiction story, TCP/IP allows devices of all sorts and from all kinds of manufacturers to understand each other. Whether it's a smartphone in South Korea, a server in Sweden, or a laptop in Louisiana, TCP/IP ensures that they can all connect and share information seamlessly. But how does it do this? Well, the magic lies in its layered architecture. TCP/IP is composed of 4 layers: the network interface, internet, transport, and application layers. Each layer has a specific function and communicates with the layers directly above and below it. This division of tasks allows for flexibility and robustness. If one part of the system fails, the others can still function. Another key facet of TCP/IP's importance is its role in routing data across the internet. Every device connected to the internet has a unique IP address. When you send data from one device to another, TCP/IP breaks down the data into packets, labels each packet with the source and destination IP addresses, and then sends them off into the network. The packets might take different paths to reach their destination, but once they arrive, TCP reassembles them in the correct order. This ability to break down and reassemble data makes the internet incredibly resilient. If one path is blocked or slow, the packets can take another route. This is why, even when there's a major disruption like a cable cut, the internet as a whole keeps humming along. Lastly, TCP/IP is open and standardized. This means it's not controlled by any single company, and anyone can build devices or software that use it. This openness has led to an explosion of innovation and has made the internet a platform for the whole world to connect, create, and collaborate. Without TCP/IP, the vast and diverse internet as we know it today would not be possible. So what have we learned about TCP/IP today? Well, we kicked things off by diving into the world of networking, setting the stage for our main subject, TCP/IP. We discovered that TCP/IP, or Transmission Control Protocol, Internet Protocol, is a suite of communication protocols used to interconnect network devices on the internet. It's the core fabric that allows our devices to talk to each other and the web at large. We then took a deeper look at how TCP/IP actually works. It's a 2-layer process. The Transmission Control Protocol handles the assembly of data into packets before they're sent over the internet, and then the reassembly of these packets once they reach their destination. The Internet Protocol, on the other hand, is responsible for addressing and routing these packets to ensure they get to the right place. In simple terms, imagine TCP/IP as a sort of digital postal system. TCP is like the packing and unpacking department, making sure your message is properly bundled up for delivery and then put back together once it arrives. IP, then, is like the mail carrier, deciding the best route for your package and ensuring it gets to the right address. We also explored why TCP/IP is so crucial in networking. It's the standard language of the internet, enabling seamless communication between billions of devices worldwide. Without TCP/IP, we would not be able to browse the web, send emails, stream videos, or do any of the countless things we rely on the internet for every day. So, to wrap things up, TCP/IP is the unsung hero of our digital world, working behind the scenes to keep our online lives running smoothly. It's the magic that allows us to connect, communicate, and collaborate across the vast expanse of the internet. And that, folks, is the magic of TCP/IP, the language of the internet.